Hello, everyone. Welcome in. Hello, everyone. It's me, Chauntée. I've missed you guys. I feel like I haven't been here in a minute or two. I feel like I've had other people helping run this, so it's fun to be back. If you're new, welcome. We're so glad that you're here. We are going to talk about computational thinking today, and I'm really excited to talk about it. I am right now in Vincennes, at Vincennes University, Vincennes, Indiana. So I did a training today here, so that's why I am still here. So I am doing this from afar, so not in the studio today. But I'm really excited to talk about some nerdy things with you, and hopefully get to do some discussing about computational thinking. So without further ado, let's do this. All right, so we're going to learn about Think Like a Coder. So today we're going to talk about fun ways to bring computational thinking into any classroom. I'm going to do some talking about some secondary and also elementary school and some ways that you could bring to life your computational thinking in your classroom. So first and foremost, what even is computational thinking? If you're new to it, I am going to explain it to you. So what it is a strategy that involves using algorithms to solve problems. So if you think about even just real world problems, not necessarily just computers, because oftentimes everyone says, oh, computational thinking, that's computers. And yes, that is computers, but it's also our day-to-day life, which we're going to talk about in a little bit. So you can see on the screen here that we're talking about 4 different pillars of computational thinking. We have decomposition, we have pattern recognition, we have abstraction, and then algorithmic design. So what we're going to do is kind of hone in on those for a minute, talk about what they are and get a little more in depth into that. And then we're going to zoom back out of thinking about those and looking at it at a broader sense. And hopefully when you leave here, you'll have some ideas on ways that you can bring this into your classroom. That's the goal. So as we talk about this, please feel free to ask questions in the chat. If there's things that you feel like I'm missing, or if you're questioning what I'm saying that you disagree or agree, come at me. I love having these discussions because that's what this is about for me, is ways that I can learn from you while I teach you what I know. So here we go on decomposition. So decomposition is taking a problem and just breaking it down into smaller pieces. As a math teacher, I use this all the time. It's about understanding how each step leads up to this final project. So you can see in the picture of this person who has this project and then just breaking it down into smaller and smaller pieces to make it more digestible. And then we have pattern recognition. And this is where you're helping students find similarities and patterns in things like problems to help them so that when they see a problem or see a pattern that they've seen before, they immediately pull that recognition from their head and say, oh, we've done this before. Remember, these are the steps. This is really common in algebraic equations because they'll learn the base of like a plus 3 equals what, and they're starting to learn that whole concept of algebra, but then that gets made into more complex questions, and that base that they learn comes to play, and they're like, oh, I remember this pattern recognition. I remember you're trying to get the letter by itself. So that's this concept that we use all the time in math a lot. I'm going to use math because I'm a math nerd, but also science, reading. You're like, remember, this is a pattern that we use where we have these thoughts. So we're looking for this concept in there, whether it's what is the big idea? And they're looking for ways to help them find that big idea. So it's that recall that they bring back up and say, oh, I recognize this. I remember how this works. And then abstraction, which is probably, in my opinion, the hardest one to teach kids because it is not so attainable quickly. It's a little more complex, but they have to figure out parts that are efficient and accurate to help solve their issue. It is, again, a really hard problem for them a lot of times. But I will say one of the ways that I think about it is this concept of 3D shape and then 2D shape. So you think about taking a 2D shape or a 3D shape and breaking it down to a 2D to help kids understand it before they get to that point. So you're taking it smaller, and then eventually you do teach students about cubes and what cubes are. But in kindergarten and first grade, they just see a square. That's that concept of abstraction. And again, it is really complex sometimes for them to be able to do, but getting them to hone in on what do they need to help them solve this problem. Pick that spot and then work from there. And then with algorithmic design, this is that algorithm, those steps, those rules they have to follow. So again, like the scientific method, they have to work through all those steps to get to an actual result. And the importance of making sure you hit every step, whether you're coding, which again, coding is a big part of algorithm, but it's also in everyday life. In the morning, if you have a routine, that's an algorithm. You get up in the morning, you're like, okay, I get up in the morning, I have a cup of coffee. I do anyway. I brush my teeth. I do these things in order. Usually I do it in an order because it helps me remember to do every single thing I need to do. And that's the same thing with computers. They have to be told every single thing they need to do, or they won't know what to do and they're going to miss a step. So this is really imperative in teaching people how to code, but also just in helping them understand how important steps are. My dad's a chef. He loves to cook. It's important that he remembers every step. And if you skip a step, it's probably not going to taste the same, right? So that's a really important concept. All right, cool, Chauntée. You told us that. Great. But that's nice. Like, what is the point of all this? Thanks for asking, people out in the universe. I would love to tell you. Sorry, I'm kicking the camera. All right, so decomposition. I like to use ice cream because who doesn't like a good sundae? So you have those bananas and the ice cream, and you take it out, and now you have each little piece, right? So this example I like to use is planning a school event where you have to divide the tasks into different things. So, okay, I need to do decorations, invitations. I have to plan activities. It's a really important concept for kids to learn, but also as adults, like if we don't have it broken down, oftentimes, again, we're going to miss an important key part of that. So I often use it in English language arts, where we take a story and we break it down into main events. And any English teacher out there, or anybody who is really involved in English, knows how important it is to be able to identify the different parts of the story so that you're able to properly tell the story. And that's that part of decomposition. In a high school setting or a middle school setting, I would have students pick a research topic. It could be maybe climate change or a historical event. They take that and they're going to identify a problem, gather data, analyze those results, and write a conclusion. Making sure they have primary sources. Organizing key events could be a thing that you do in history, or maybe in English, you're going to take main theme or character development and have students create a timeline or a task list with deadlines for each part. So if identifying a problem is the first part, which it should be in science, you have that. How long is it going to take you? And they draw out a timeline. It really helps the kids, and those kids who are struggle with getting big chunks of things done at one time. Me, I do better if you say, here's the first task, get this done. This is when it needs to be done by, then this, and I see a timeline. It makes it way more doable than you saying, hey, I need you to do this. So that's the importance of decomposition for kids, is that concept of like, break it down for me, make it smaller, make it easier to process. And then with pattern recognition, again, I have ice cream on here. So you see a repeated pattern going on. So that math sequence or analyzing weather data is really important for kids to understand that concept. Oh, today is, well, it's Indiana where I live, and I don't know where some of y'all know what your weather is like, but the weather today started out being a certain way and now is something different. So you might wear a t-shirt in the morning, and then when I got out of work, I'm like, whoa, it's freezing, put on a sweatshirt. So sometimes it's hard to analyze data and see a pattern if you have a state like this. But in a state that is more consistent than Indiana, you would see these analyzing these patterns and helping kids understand there's patterns all around us, whether it's the weather, whether it's the way we do things, like every day we do these things in this order, and they start to repeat it. And then they recall that and say, oh, I know what happens next. because I remember now. And it's part of that algorithmic design when you start seeing these pattern recognitions. So for instance, I know a lot of y'all have probably seen it or done it yourself where you have these rules and you're trying to figure out what is this rule in this number pattern or the shape pattern. This one is really common for kids who are gifted to be able to identify like super fast. So if you have kids who are seeing patterns in everything, a lot of times those kids who are kind of the outside the box thinkers. But I will say this one is a little more comfortable for people because it's like, oh, I recognize this. But those gifted kids are usually able to identify like those number patterns and say, oh, it's -2, which is beyond me to understand how quickly they do that. But that's pattern recognition. And then for high school with that, providing students with data, whether it's monthly temperatures or sales data of some sort, ask them to use a tool like Excel or Google Sheets, which I never used when I was younger, but I can see how much I would have benefited if I would have started charting things more. But create a chart or a graph to help them visualize and identify pattern trends. Like, oh, it's starting to seem like every April you're seeing this more, and then in June you're going to see more of this. And like give them a chance to create a report or a presentation talking about those highlighted key patterns they're seeing and making predictions about what's next year going to look like. I think it is really fun to see kids process that and make the connections to sales, like iPhone sales. You'll see them skyrocket at a certain time. That's because there's a phone release happening. But to see kids recognize that and say, oh, I know why. This is what's happening at that time. And I've been identifying those outliers too. And so it's a really helpful way to help them start to be able to recognize patterns around them in the world that they're living in and be able to apply it to something they're comfortable remembering. Like, oh yeah, this is when this happens. When Marvel movies are released, suddenly movie tickets go up. At least I go to the movies when they're released. So you'll see that happen. Why? There's a big following of that. With abstraction, again, it's a little bit harder for kids to understand, but for this one, I like to do things like maps because they can identify those landmarks on the maps and help them to be able to realize what the map is saying. I feel like that on blueprints too, where I look at them like, I don't know what this means, but to be able to recognize on the side, help from that, to be able to hone in and say, oh, that's what this is. That's what this is. The rest of that stuff doesn't matter right now because I'm just looking for where is there a lake or where are there rivers flowing. To have those landmarks to identify, it really does help kids be able to pull that instead of seeing this busy map. That's an example of that is those maps and identifying those maps. All right, but in high school or middle school and also upper elementary, you can do things where students work in small pairs and design an interface for an app, and they'll have to focus on a key feature of that app. So let's say that they're saying, oh, I'm going to design an app for mental health check-in. So they decide which feature is going to be the most important for that app. Is it a clear display of like emotions, and they have to pick a certain emotion that they have to be the hone in of that emotion? Well, let's say it's sadness. Then the students hone in on that sadness and make sure that they identify why are people feeling sad. Or maybe it's more important that it's just simple to the point. But telling kids to pick out one thing that you're going to make sure comes to life on your app. What would it be? And hone in on that. The app is the big idea. That one concept is the abstraction from that. And have them mock it up and explain what the features are and why they focused on certain features and why was that important to them. And then with algorithmic design, again, you have those students who are learning about what it means to tell directions. And I'm sure every single one of us have done the activity with our English teacher where the English teacher says, oh, hey, tell me how to make a peanut butter jelly sandwich. And then you have to design or write down the directions, and you realize how much you did not tell that needed to happen. So I'm sure, again, I'm sure most of you all have done that, but that is a great way to understand how important every step of the algorithm is to the completion of a task. And that's why with my students, I've done where they're a human robot and you have another student telling them directions to get somewhere. If you really want to throw them off, you can have the person who is the robot blinded. So you put like a towel over their eyes and they can't see, and then tell them, okay, follow these directions. And they only can do what they're being told to do. And it really does help them understand, hey, if I'm not very clear, they won't know what to do. And that's how robots are. If we don't tell them, hey, I need you to do this, 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 it won't know all of those things. In my elementary classroom, when I taught ESL, I had my kids teach me how to wash my hands, and I did it in front of them. And I would take their directions and do it. And it was so fun for them, and also so fun for me, because it was like, okay, you're telling me to dry my hands, but I don't know what dry my hands means. And so I went over to one of the kids and pretended I was going to dry my hands on their shirt, and they're like, no, not me. But it makes it a lot of fun and also brings it to life in a different way. Of course, if you're teaching older kids, it might not quite look like that. But that concept is really fun to do. I don't know why it's frozen. There we go. All right. With algorithmic design, with the older kids, I've done things like design and code a simple game or a simulation. If you have microbits, or if you have Kaibots, or if you have any of the robotics, this is where they come into play, of allowing kids to actually create an algorithm with code. Whether it's going to code.org and doing that, it works too. But creating a working game or a simulation along with a flow chart to the side, explaining the steps. And I tell kids that if you can write down your steps of a code and someone else can copy that, then you're understanding that a lot better, because somebody actually can follow those. With my younger kids, I have them do one with paper and just little arrows on the side. They lay it all out, and I give them physical little plastic bugs. And I say, hey, if there's a bug in their code, just drop a little plastic bug on their code. And then the kids are like, love it, because it's plastic bugs, and who doesn't like playing with that? But also it teaches them the vocabulary, and also gives them a chance to give feedback to someone else. So I say, lay out your algorithm. They lay out the arrows, and they have a little maze there. And I tell them, now let your friend try it. If they can get through the maze following your directions, then you did a great job. If you have a bug, you got to come back and fix it. And it's a lot of fun because it creates problem solving in the classroom, which opens the door to a lot more of discussions about why did it not work? Well, this was the problem. Well, what did you do to fix it? Talk to me about how that worked. What was the issue? What did you figure out was the thing that solved the issue? This is something I thought was really fun, so I wanted to show it to you. I apologize that my slides are not as fun as they usually are, but there's so much content in this that I wanted to make sure that I put on the screen in front of you to see. So I apologize, but also I don't. So I do and I don't. But presenting a real world problem like reducing plastic waste in the community, having them identify a major problem of plastic waste, and the impact is decomposition. For them recognizing a pattern, they're analyzing trends in plastic use and recycling rates, so they can pull that information. Then with abstract, they need to focus on some key behavior or factors. So maybe it's consumer behavior, maybe it's us, the problem, maybe it's recycling availability. There's nowhere to put recycling. But then also learning to ignore less relevant details. That's when I say the abstract becomes really hard. If you think about like big word problems, and kids don't even know what part to cross out that they don't need to solve the problem because there's so much words in there. So helping them find a way to hone in on that small issue instead of looking at it super big, saying, what is it they're asking and what can I get rid of, to focus on things that really matter. And then designing an algorithm, a step-by-step plan for reducing plastic waste. And this gives them a chance to really take that and apply it to real world application. What's happening around us? I really like it when my students find things that are in the community that is a need for somebody to fill. So maybe in the community, there's not a playground, or maybe there's not a dog park, or whatever it is that they see in their own neighborhood, and take that and have them do it with that. Something that they can really actually take into practice and apply it to something in the real world around them. All right, so before I do too much further, I'm going to pause for a second, take a deep breath. I know that was a lot in a short amount of time. And if there's questions, know that you can ask them. If you need me to go back and review some of the stuff, I can also do that. But I just want to take a breathing moment. Hopefully everyone's still with me and we're plugging along. I'm going to actually take a drink of water if I can real quick. All right. Nothing. All right, we're going to move on. We're nearing the end of my part. So just know that I'm going to open up the floor to you. All right, so this is my favorite way to bring it to life because I'm a big fan of lasagna. If you're not, I apologize. But this is a way that really does help it really bring it to home for me. So in making a lasagna or making anything, you have breaking it down, the recipe, and figuring out what steps you need to take to be successful. Because I know nowadays it's a blog post, it feels like, that I'm reading to figure out how to make something. It's like, wow, there's so much information. So let me just grab what I really need, pull out what I need, break it down, start to layer, and you see those layers happening when you start making lasagna. So you put down the noodle, the cheese, sauce, noodle, cheese, sauce. After a while, you don't have to look at the recipe because you're like, oh, I got this. I'm feeling myself. I've got this. And that's when the pattern abstraction or the pattern recognition comes in, where they're like, oh, yeah, I don't need help anymore. I've got this from here on out. That's that whole concept of the repetitiveness. The more we repeat something, the easier it is to recall it. And then once you're done, you've made a tasty dish, right? But you also can explain the process you did. So if someone said, oh, this is really good, what did you do? You're recalling those steps that you did to make that lasagna and explaining it to them. That way they don't have to go read the blog post that was made for how to make this meal. But to me, this is a really easy way to understand it, for me anyways, because I like to cook. But okay, great. Where do I start? And this is the part where I say to you, it's okay if you're like, I can't do technology right now. I'm a little overwhelmed. Well, why don't we start with coding unplugged? This is where you're using the concept, just like the human robot thing. You're using that concept where they're learning it, but they're not actually having to learn technology at the same time. So once they get these concepts, then bring in technology and they're going to be flying because they don't have to learn the computational thinking concepts and the technology at the same time. They're only learning something new, and that is the technology. So this is how, especially with the younger kids, this is how I start. No technology, coding unplugged. There's a website called Codable that I like to use that has free resources. So if you haven't used that or you want a place to start, it's a great place to start where you're not using anything and then eventually bringing in concepts. So for this, just like key concepts in that technology, I have a map or a maze down there on the floor, on the ground that there's a picture of, and that's just tape and then little squares that they can't go into. So when it comes time to make it a little more challenging, I will put little blockages throughout it and say, now you got to figure out your way through it. They're just using arrows and moving like little game pieces or like a car, and they're maneuvering through this. And it's great. It's fun. The kids are interactive with it, and it's not super heavy. But it's a way to kind of bring it to life. I've even done this with older kids, and they really like it too. Not with like cars, but more like bringing a game board to life and saying, okay, but you have to tell people how to make it through your game board and avoid traps. And that's a lot of fun as well.